All right, so let me maximize this. There we go. So in math, we use variables to represent some unknown quantity. Okay, it's something we don't know. Okay, now on the flip side of that, a constant is a known quantity. So variables get letters. Constants are numbers. They always stay the same. Okay, does that make sense so far? Are there any questions with that? Okay. Now, excuse me. Now, if we kind of just take this definition and kind of, I guess, extend it a little bit, okay, we have something called algebraic expressions. So, let me write out the definition first. So, an algebraic expression is a mathematical statement that contains the following things. Now, it doesn't have to contain all of them, but it's going to have at least one of these. Okay? The first one is a constant term. Okay? The second is going to be what we call a variable term. And then the third are just going to be some math operations. Okay? Now, let's talk about what the constant, the variable terms are, math operations. The easiest one, math operations. That's going to be add, subtract, multiply, or divide. That's the easy one. You're definitely gonna have stuff like that in there. Okay? Now, a variable term will look something like this, like 3 times x. So when we write the 3 and the x right next to each other, we read that as 3 times x. Okay? So a variable term is 3x, or it could just be the letter y. It doesn't matter. It's just that unknown quantity. And lastly, the constant term, negative. I don't want to use negative yet. 4, 8, 16. Notice they are just numbers, and we know exactly what that quantity is. Okay? Now, when we say term, like constant term or variable term, terms are separated Is that how you spell separated? Is it S-E-P-A or S-E-P-E? I think it's E. Terms are separated by either the addition symbol or the subtraction symbol. So, for example, 3x plus 7 has two terms. The 3x is the variable term. The 7 is the constant term. And like I said, there are two terms there because that plus sign in between them separates them. Three times x times y only has one term. And the whole thing is a variable term. Okay, do we see the difference there? Because it's really important that we know this. And it's really easy to get. All right, now there is one more thing I want to go over. Actually, let me do this. So if we have something like 7x minus 1, we know there's two terms. We know that the 7x is the variable term, and we know that the 1 is the constant term. That 7 has a very special name. That 7 is called the coefficient. And it's called the coefficient because it is multiplying the variable x. Notice that 1 is just a constant. Since there is no variable, it's only called a constant. Now, I'm telling you this because later on when we start to learn how to solve, they're going to be throwing these words out there like variable terms and constant terms and coefficients. And if you don't know the names of those, if you don't know what those definitions of those words are, how are you supposed to understand the directions? So you got to make sure that you understand this. Now, one thing that we don't have on the board yet is an equation. Notice all my examples, no equal sign. I'll scroll up a little bit. No equal sign anywhere. And that's because everything that we are doing right now is called an algebraic expression. Okay? Are there any questions so far? All right. So then the question becomes this. Or it's not a question, I'll just tell you what it is. If you have an algebraic expression equal to another algebraic expression, can't spell today at all. That is called an equation. Okay? Now, I know some of us, we've seen this before, and that's okay. But we tend to make a lot of little mistakes, and little mistakes is because sometimes we forget the difference between an algebraic expression and then an equation. So, an algebraic expression the directions will be simplify. All right? So even if I don't write the directions, assume if you have an algebraic expression, the directions are simplify, which means make it look smaller, combine like terms, something like that. When you have an equation, the directions will be solve. Okay? So there's a big difference there. How many of us have ever heard of this phrase before? Whatever you do to one side of the equation, you must do to the other. We ever heard that before?
Yes.
Perfect. So the thing is, you got to know when to apply that. You do not apply what I just said to an algebraic expression because there is no side. An algebraic expression is just a statement. An equation has a left side and a right side. Does that make sense, everyone? Are we sure? Because this is like a lot of definitions thrown at you. This is a lot of like hopefully filling in gaps. All right. So let's evaluate some expressions. All right, so we got a really easy problem here. We're going to let x equal 3. And what we're going to do is we're going to simplify x plus 7. Okay? Now, what that means is that we're going to evaluate, which means basically just tell me what this is simplified. So, directly underneath, I'm going to write x plus 7 again. Whenever I make substitutions in math, I always put parentheses first, and you'll see why later. Just for now, I'll just get in the habit of that. And all I got to do here is just say, okay, well, I'm going to substitute in a 3, and then I'm going to evaluate. 3 plus 7 is 10. And that's it. That's as hard as it gets when we talk about evaluating expressions. It's an expression because it has two terms. One's a variable, one's a constant. And then the evaluation part is saying, okay, well, what if we let x equal this number? Tell me what it is. Does that make sense? Now, let's try another one here. So evaluate x times y. If x equals 7 and y equals 5, directly underneath, I'm going to write x times y. Then I put my parentheses in, and I make the substitutions in the appropriate spots. 7 times 5 is 35. Pretty straightforward. What do you think? All right. Here. Oh, Lakendra, do you have a question?
No.
Okay, I'm sorry. Here's one. Let's try this. How do I approach this problem?
Would it be 2 times 2 times 2?
How did you get that?
I don't know. I just know that. I don't know.
Do you know what that's called? Here.
Like the power of 3?
Yeah. What is that called? What is that little 3? You're correct. I mean, everything you said's correct.
On it.
Ah, there you go. Okay. You too. Thank you. So to evaluate this, this example, we need to learn about exponents. So, Kimberly, what is an exponent? What does an exponent tell us?
It just tells us we need to multiply that number that many times.
Okay, now, I agree. I agree 100%.
Number beneath it that many times.
Okay, see, now we need to be more specific, because when you say
Okay,
that number, I'm
number
like,
to the power of, shoot, I don't know how to explain it. I don't know.
no, you're fine. So let's dissect a little bit of what you said. The 3 is called the exponent. Do you know what the 2 is called? It has a name. And it's okay to say, no, Mr. Float, I don't remember it at all.
Yeah, I guess I don't remember it.
It's called the base. Okay, so the 2 is called the base. The 3 is called the exponent. And this is red. Two to the power of 3, which means we're going to multiply the base however many times the exponent tells me. All right? Mathematically, and this is our like real first definition here, a to the n means multiply n factors of a. Another way to write that is like this. All right, so this is very mathy. So take a minute, write it down, and then I'll explain it, okay? Hi, buddy. Ow, ow. Okay. So you got the base. Oh, I'm sorry.
Can you just scroll down a little bit? My Zoom had like it cut out and I had to log back in.
There you go. That's all we did.
Okay, thank you.
Yep. So with an exponent, we take the base and we multiply it n factors of a, which means whatever that exponent is, all you're going to do is write the base that many times with the multiplication symbols in between. And that's it. So the in black all the way at the top of the screen, evaluate x to the third if x equals 2. I'll just write it down here. 2 to the third equals 2 times 2 times 2, which is 8. Okay? Now, there are like little shortcuts when we're talking about certain exponents. For example, let me write it like this. Different names. We'll call it different names. And I know we've heard this before. If we have an exponent of 2, we could just say squared. In this case, this is going to be a squared. We've heard that before. Can anybody tell me why we say a squared? Like, how do we know that 2 means squared? You all know the answer to this. Now this is where we're going to start making connections. You remember back in... Oh, I'm sorry. Go ahead.
Sorry. Isn't it because anything to the second power, you're going to find, like, the square... Like, I guess whenever you're doing, like, perimeters and stuff, you get, like, the square footage? No?
Yes, you're using a lot of words there. Yes, but Stevie, I like what you're saying, so we're going to build off that. First, we didn't need the word perimeter. Perimeter is just a line.
Yeah.
Now, back in chapter 1, section 5, or section, let me look real quick. Back in chapter 1, section 4, we learned about multiplication and we learned about area. And we learned that if you have a square and you take the length times the width, that gives you area, which is square units. So that's why when we have an exponent of a 2, we just say it's squared, because we know we're only multiplying two numbers, just like a rectangle. The other one is a to the third power. We call that a cubed. And the reason why we call this a cubed is if we took that square and then made it a three-dimensional object, and we multiplied the length times the width times the height, notice you are multiplying 3 units of measure now, which is a volume. We say that's a volume. Okay? But since we're multiplying 3 units of measure, it's a cubed, or whatever number it is to the third power. Does that make sense? Stevie, I missed you earlier. I got a question for you.
Mm-hmm.
Did you come in to the Zoom room last night at like 9 o'clock at night?
Yeah, I did, because my computer video wasn't working for Zoom, so I've been using his, but he started school today, so I was like, well, you need to fix my computer.
Okay, no problem. No problem. No problem. All right, so what I want us to do right now is I'm gonna give you expressions, and I want you to convert them back into what we call exponential form. Now, exponential form is right here. This is exponential form because it contains an exponent. All right, and we're not going to do we won't do too many of these because I think once you see it, you get it. So here are a couple examples. Write in exponential form. I'm writing the number 3 a lot today. All right, so go ahead and do those 3. All right, do we have answers yet? Who got part A?
4 to the 5th power.
I love it. What about part B?
I put x to the 6.
I love it. Good job so far, everyone. What about part C?
21 to the 3rd.
21 to the 3rd power. Perfect. Now, the opposite way would be if I just read the directions, simplify, and I wrote something like this. Uh-oh. C. We'll do 2 to the 5th. So now what we're doing is we're taking exponential form, and then we're converting it into the actual simplification of whatever it is. So, for example, the first one is 3 times 3 times 3. Now, the hardest part about this is you literally have to do the math. 3 times 3 is 9. 9 times 3 is 27. That one was nice and easy. Part B is even easier. Y to the 8th. Well, you have no idea what y is, and that's fine. But what you do know is y to the 8th means y times 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 y. So y multiplied 8 times. Okay? Now, the hard part, I think, is part C, 2 to the 5th, only because it's a lot of multiplying. So, first we write it out, 2 times 2 times 2 times 2 times 2. Now, personally, what I will do here is just group them up. 2 times 2 is 4. So we have 4 times 4 times 2. We know 4 times 4 is 16 times 2. And 16 times 2 is 32. Okay? And that leads me into the big topic of the day. This is the biggie. Ashley, are you ready for the big topic of the day?
Yes.
All right. Somebody tell me what that simplifies down into. I'll give you a minute.
Is it 4?
I didn't say give me the answer yet. I just said simplify it.
Sure.
It's okay, Kimberly.
16 divided by 16.
I'm literally going to ask for the answer in a minute. This is not a trick question. Okay. So, since Kimberly and Stevie already said something, Kimberly, what was your answer?
4.
4. Stevie, what was your answer?
1.
Oh. Uh-oh. Ashley, what did you get?
I got 1.
If you can, there's that, add a reaction on Zoom for me. Raise your hand. You could just click on the add reaction, click on a little hand thing. Raise your hand if you got 1.
Oh, I did the wrong one.
You're okay,
Is that a
Stevie.
clap?
It's a clap. She's very excited. All right. Give me an emotion if you got 4. Okay, so we got more 4s than we got 1s. What is the technique that we have to know in order to simplify this problem?
Order of operation.
And Stevie, absolutely correct. What?
PEMDAS.
Oh, yeah, and I hate that. I got to be honest with you. I hate that. So,
Hold on. Can I say something that I just learned this year about this?
hold on. Who's talking?
Tim.
Yes, you can, Kim.
Okay, so I was also taught PEMDAS like 11 years ago when I was in school, but I recently just learned you don't actually have to do like them in order. So like multiplication and division is whichever comes first.
Yes.
I was taught that you had to do it in order.
Yeah, and
I
that
would get it wrong all the time, and it's not true.
no. So
Yeah.
that is why I hate when people say PEMDAS, which is nice, it's easy to remember. Or the other one I really hate is please excuse who?
My dear Aunt Sally.
We don't excuse her. And here's what happens. When you remember PEMDAS and when you remember please excuse my dear Aunt Sally, and Kimberly nailed it, you think multiplication comes before division, and that is incorrect. Now, here's your book. I'm looking at your book. All right. And it says right here, it's good that my dear, and that my dear and Sally, it's good that my dear goes together, as it reminds us multiplication and division have equal priority. We do not always do multiplication before division or always do division before multiplication. We do them in the order in which they appear from left to right. All right? What's that?
When did that change?
It's never changed. It's been like this.
Yeah, I just remember like way back in high school, it's just always been like, do it in 10 this way. Like,
Honestly, Stevie, I'm going to make a massive assumption, and we know what assumptions do. They make us look like something, okay? I'm not going to spell it out, but I'm sure you've heard the phrase before, all right? What it does is I think you've had teachers teach something for so long and students don't remember it, so they create a cool way for students to remember it. And unfortunately, in K through 12, we focus a lot on memorization. I mean, look at all the standardized testing. That's why math is a very difficult class for students. It's because you can't memorize. You got to be able to apply. You can memorize, please excuse my dear and Sally. But then when I give you a problem like this, we get the answer is 1 or the answer is 4. And it's because math is about application. I'm telling you, math is a simple subject. All you got to do is study the rule. And the rule is what we're going to go over right now. Okay? Once you know this rule, it doesn't matter what problem I give you. You follow the steps. That's it. So, order of operations. This is how I like to write it. Stevie, I'm going to use your quote next time I'm with some of my colleagues. I'm going to go, yeah, I had a student go, when did it change? It never changed. So I like to write it in a stacked order because, you know, when I read stacked lists, I always think, okay, the top one is first, second one's third, or second, and so forth. P stands for parentheses. All right, they can look like this or brackets. You always do anything inside parentheses first. Think of it as like a bear hug, and it's holding everything together. You got to do that stuff first. Okay? Second, exponents. We just learned what exponents are. You always want to simplify exponents second. So do everything inside parentheses first, then look for any exponents in the problem and simplify them. Now, this is where I put the star, because this is where everybody goes wrong. Multiplication and division are equal. That's why they're on the same level. But you always do them from left to right in order. And then lastly, addition and subtraction. It's the same. They're on the same level, therefore they're equal. But you do them left to right in order. So for our example, if you read it out loud, you will know the order. 16 divided by 8 times 2. We are forced to do 16 divided by 8 first because division and multiplication are equal in terms of priority, but you do them from left to right. So 16 divided by 8 is 2. And lastly, 2 times 2 is 4. So the answer is 4. Elijah, you have your hand up on your screen. Do you have a question? Same with Lakendra.
No.
I was giving my hands up for 4.
Yeah, no, yeah. I don't know why it hasn't disappeared yet. Everybody else has disappeared, but that's okay. Oh, now it disappeared. Don't worry about it. We're good.
I didn't know I had to hit lower hand. My fault.
Oh, you have to lower it?
Yes, sir.
Oh, I didn't know that either. I learn something new every day. All right. So are there any questions with this thing that we call the order of operations? All right, because we're just going to do a bunch of problems now. Because this helps us to organize our thoughts. Remember, we've all been in this situation where you look at a problem and you look at me and you go, I don't even know where to start. You got to know what you're given. So if the first thing I would ask you, like if I gave you a problem and you looked at me and said, Professor Float, I don't know where to start. The first thing I would ask you is, are we simplifying or are we solving? Okay? If you say, well, the directions say simplify, then I would say order of operations. Does that make sense? All right. So let's do some examples here. Crystal, how you doing today? You've been quiet.
I'm good. I'm just learning a lot that I haven't learned in like 15 years.
Isn't it nice to learn?
Just cleaning up my slate of whatever I learned from what Kimberly had said. Everything I was taught was wrong, so I'm just trying to take it all in.
I don't want to say it's wrong, because then what I'm doing is I'm saying that your old teachers were bad. Meanwhile, they could have been really good. I don't know. But there's one thing that I don't do, and that's take shortcuts. So I write things out. I ask questions. I don't take shortcuts. I hate shortcuts. How many of us, and this is beyond the scope of the course right now, how many of us have heard of FOIL in math? Anybody remember FOIL hearing that? Yeah. I hate that thing. So if you have me for Math 90, which I hope you do, I'm teaching Math 90 in the spring. I don't know when, but I can guarantee you I am. When we get to FOIL, you will hear me. I will give you a 15-minute soapbox speech on why I hate it, and it's horrible because it teaches you how to do things incorrectly. Boy, I really can't stand math sometimes, how people teach it. But anyways, let's get back to this. First thing you always want to do is read the problem. 12 minus 5 times 2. Now, what I like to do off to the right is I'll do a little abbreviated order of operations list. Took me literally 3 seconds to write that. And then I go right down a list. Do I see parentheses? No. So I scratch it out. Do I see exponents? No. So I scratch it out. Do I see anything multiplication or division? And the answer is yes. I see 12 minus 5 times 2. So I have 5 times 2, which is 10. So I'll connect them and just write 12 minus 2. Notice when I connect them, the result is directly underneath. So then I read it one more time. 12 minus 10. I didn't say multiplication nor division, so I scratch it out. And now, addition and subtraction. I got subtraction. 12 minus 10 is 2. And circle it. Notice there are no equal signs anywhere in here, and that is because I am not solving. I'm simplifying. Don't put in equal signs. If you want, put arrows. Look above. Here, here, and here. They're arrows, which means I went from this spot over here. Okay? I don't put equal signs. When I solve, I put equal signs in. Does that make sense, everyone? Okay? All right, now I'm going to give you one to do. Actually, I'm going to give you 2. And we're going to see just how different these 2 problems are. There you go. Hi, Arthur. Good morning. Good morning, my lovely puppy. So, okay, try those 2 for me. Okay, we ready? Or do you need another minute? I see some people with their heads down. All right. So what do we get for the first one?
35.
35? Okay, let's see if that's correct. So I'm going to write my PEMDAS. Now I go right down a list. Do I see parentheses? No. Exponents? No. Multiplication or division? I definitely see that. 3 times 9. It's going to be 27. Let me write it cleaner. There's no more multiplication or division. All I got left is to add. 8 plus 27. 35. Who gave me that, LaKendra?
Yes.
Man, you have been on fire today. Do you know that? Did you eat breakfast? What did you eat for breakfast? I want some. Nothing. Man, you are on point today. I love it. All right, for the second one, and you're going to see how this is different. Here, I see parentheses. So what I need to do is all the work inside. And inside the parentheses, the order of operations still applies. So if you see exponents inside parentheses, you got to do that. If you see multiplication or division inside parentheses, you got to do that. Here we just see addition, which is nice. So 8 plus 3 is 11. So parentheses are gone. I don't see any exponents. I do see multiplication. 11 times 9. 99. And that's it. How are we looking so far? Does this make a lot more sense now?
Yes.
All right, let's keep going. Let's keep going. Because I do have to get the problems a little bit more difficult. But what's nice about more difficult problems is it trains you to stay focused on the steps. So here we go. We have 18 divided by 6 plus 4 times the quantity 5 minus 2. This right here, and I'm gonna highlight it for us. Anytime you see parentheses with some things on the inside, instead of saying, 4 parentheses 5 minus 2 end parenthesis, we just say the quantity of. So 18 divided by 6 plus 4 times the quantity 5 minus 2. And also, I know this is going to sound, I'm really being nitpicky here. But even listen to the way I even say it. I don't say it in like one breath. It's kind of like I'm reading something, like 18 divided by 6 plus 4 times the quantity 5 minus 2. Like I give myself a break. And even by doing something simple like that, you already start to see things. So, I'm going to rewrite it so I can write my PEMDAS and keep everything nice and neat. All right. Do we see parentheses? Yes or no? I agree. 5 minus 2. Notice I write everything else exactly how it looks. Except the 5 minus 2 is going to be 3. Now all my parentheses are gone. Let me ask you a question. This is just a review of what we did earlier. How many terms do we see here? Can anybody tell me how many terms? Remember how we separate terms. How many terms do you see?
3.
I see 2. Remember, terms are separated by pluses or minuses only. Here's your first term. Here's your second term. Does that make sense, everyone?
Yeah.
All right. Let's keep going. Do we see exponents? Yes or no? I agree. I agree with Lacey. Do we see multiplication or division?
Yes.
Yes, we need to do them from left to right in order. What's 18 divided by 6?
3.
I love it. So I do one step at a time. Now, what's 4 times 3?
7.
12. Be
I
careful.
said 4 times 3.
You added them, which is a very common mistake. So, multiplication, division is done. Last, 3 plus 12, 15. Good? All right. Now we're going to get a little bit...
Multiplying it because of the parentheses?
Oh, I'm sorry. What did you say?
You multiplied it because of the parentheses?
Yes, yes. So, back in... Let me see. Back in chapter 1, section 4, we went over ways to write multiplication. You could write it with an X in between, just like...
Yeah.
Right, you know, in the upper left-hand corner. You could do a dot in between, or you could do a 5 and then parenthesis a 5. The thing is, when you see the parentheses, you always want to do the work inside, but if it's only one number, then there's nothing else you could do inside those parentheses. So then it turns into multiplication. Does that make sense?
Yes, it does.
Okay. All right, next one. We're going to get more difficult now. All right, this is a biggie. This one's a biggie. Do you want to do this together, or do you want me to let you try it? Lacey, you get to pick. We do it together or on our own?
Try it on our own.
Okay, I like that attitude. I'll give you a minute or two. Okay, are we good? Who got an answer?
I have the answer.
What did you get?
It's probably wrong, but I got 20.
20? Did anybody else get 20? Who got something different?
I got 31.
31?
I got 14.
Oh boy, we got a bunch of different ones. All right, let's take this one step at a time. We know we got to do parentheses first. Is that correct?
Right.
Now, remember, up above, I'm going to scroll up real quick. Parentheses can look like, well, the parentheses or brackets. Now, the only reason why we use both of those symbols for parentheses, the traditional parentheses symbol or the bracket, is for a situation like we have here where you would have like a bunch of parentheses, okay? So the bracket is only used visually for us to keep everything in order. Now, when we say we got to do the work inside the parentheses, what we mean is we need to do the work in the innermost parenthesis. So I have to do this first, okay? So let's go ahead. Let's subtract 4 minus 2. So I'm going to rewrite everything exactly how it looks. Four minus 2 is 2. Okay? Now, I still need to do the work inside the parentheses. In this case, the parentheses have now taken over the form of brackets. But they're still the same. So I need to multiply 3 times 2. Because remember, if you look inside, that says 6 minus 3 times 2. So I got to do the multiplication first. So I write everything exactly how it looks. And 3 times 2 is 6. Does everybody agree with me so far? Okay. So now, I still need to do the work inside the parentheses. So that's going to be 6 minus 6, which is 0. Notice I write everything exactly the same. And once you get down to this situation right here, where there's only one number, if you want to, you can change back to parentheses, or you can still leave it as brackets if you want. The only thing you got to do is just train your mind that brackets are the same as parentheses. Again, I need to figure this out. So 5 plus 2 to the third power plus 3 times 0. Notice, no more parentheses. So finally, after 3 moves, I'm done with the parentheses stuff. Next would be exponents. Well, I see exponents right here. 2 to the third power, if you need to, go off to the right-hand side. Let's see, that's going to give me 4 times 2, which is 8. So this will be 5 plus 8 plus 3 times 0. So now my exponents are done. Cross it out. 3 times 0, I need to do that first. So that's going to be 5 plus 8. And 3 times 0 is 0, so I'm not even going to write it. Lastly, 5 plus 8 is what? 13? 13. So the answer is 20, 31, and 14. I forget who gave me them. Do you see where you made your mistake now? Okay? All right, because that's the most important thing. Like, I am 100% okay with mistakes. That's why you're here. You're here to learn. All right? I just want to make sure that you see where you made your mistake, and then you understand why you made it, and then how not to make it again. All right? Are we good?
Yeah, I didn't know we were supposed to. I messed up because I didn't multiply the 3 by the 2. I just subtracted the 6 minus 3 and then just brought down.
Yeah, you violated the rule. You violated the rule, which honestly, Lakendra, that is. So the very first problem we did is the number one mistake. The second mistake would be doing what you did, which is subtracting the 6 and the 3 at the very top. Yeah, all common mistakes. Let's try a couple more before the class is over. I'll give you this one. Also, and I know, like I said, this is where I feel so bad because I get so nitpicky. Write large, write neat. You'd be surprised on how many mistakes you'll stop making if you just write large and write neat. Okay, anybody got an answer yet?
3.
3.
1. I got 1.
We got a 3, we got a 1. What else? All right, let's try it. Remember, order of operations. Do we see parentheses? Absolutely. And we see a bunch of them. So we got to go to the innermost parenthesis. 5 plus 1. So I do not skip steps. I write everything out exactly how it looks. 5 plus 1 is 6. Okay? Now, excuse me, am I done with my parentheses? No. Because I still have 4 times 6 inside the big brackets. So I need to do that. So I rewrite everything exactly how it looks. 4 times 6, 24. So now I'm going to go ahead and ask myself, am I done with parentheses? The answer is yes. Exponents. Well, I see it right here. 7 to the second power means 7 times 7. So that's going to be 49. Now I take a second. Am I done with my exponents? Absolutely. Now I'm worried about multiplication or division. Well, I definitely have multiplication. 24 times 2 is 48. So 49 minus 48. Multiplication, division is done. And 49 minus 48 is 1. Okay? Are there any questions? Yes or no? All right. Well, I am going to call it there.